Hey students, welcome back. So let's review all the reactions of your chapter Electrolysis in one shot. So let's begin. Let's start with the strong electrolytes. What are the strong electrolytes? Like HCl, how do they dissociate? They dissociate completely to form H plus and Cl minus ions. Correct? So how do we write that H plus, H1 plus? We usually don't write 1, but if you see the electrolysis, it is 1 H1 plus and Cl1 minus. Correct? HNO3, it will form H1 plus plus NO3 1 minus, correct? H2SO4 will form what? 2H1 plus plus SO4 2 minus, okay? KOH will dissociate to form K1 plus plus OH1 minus. Then NaOH will dissociate to form Na1 plus plus OH1 minus, okay? Lithium hydroxide LiOH will dissociate to form Li1 plus plus OH1 minus. Okay, so these are all the strong electrolytes and how they dissociate. Clear? Next, PbBr2, okay, in the molten form dissociates and form Pb2 plus plus 2Br1 minus. Clear? CuCl2 will dissociate to form what? Cu2 plus plus 2Cl1 minus, copper chloride. Then AgNO3 will dissociate to form Ag1 plus plus NO3 1 minus. So this is how your strong electrolytes dissociate into their ions. Let's see weak electrolytes. Let's see how weak electrolytes dissociate. Very common weak electrolyte is your weak acid CH3COOH, your acetic acid. Okay, how your acetic acid dissociates? It dissociates to form CH3COO1 minus ion and H1 plus ion. So why do we call it as weak electrolyte? Because they do not dissociate completely, they dissociate only partially. Partial molecules will be CH3COOH still and some will be dissociated to form these ions, okay. Then HCOOH, your formic acid, can you see HCOOH will dissociate to form HCOO minus and H plus, okay, and H1 plus. So we know the charge on it, right? So accordingly you will write the dissociation. H2CO3, your carbonic acid, will dissociate to form H1 plus plus CO3 2 minus. This is how your carbonate ion dissociates, okay, CO3 2 minus. Carbonic acid dissociates to form 2H1 plus plus CO3 2 minus. CaOH twice, okay, CaOH twice will dissociate to form Ca2 plus plus 2OH 1 minus, correct? MgOH twice, same, Mg2 plus plus 2OH 1 minus. Let's see another one. Ammonium hydroxide. Ammonium hydroxide, that is a weak electrolyte, dissociates to form NH4 1 plus plus OH 1 minus. Na2CO3 2Na1 plus plus CO3 2 minus, okay, CO3 2 minus, like this. Next, KHCO3 will dissociate to form K1 plus, see this is different, K1 plus plus HCO3, okay. We've seen HCO3 anywhere? No, right? Yeah, so this is the first time, HCO3 1 minus, see the charge on it, 1 minus, clear? So let's see the next one. Now we have CH3COO2Pb, your lead acetate, how it dissociates. Again it's a weak electrolyte which dissociates to form CH3COO1 minus, same thing like this, and the other part, that is your Pb, will form Pb2 plus ions, okay, that's why we have 2 here, Pb2 plus ions. This is how your weak electrolytes dissociate. Let's move on to electrolysis of molten PbBr2, your lead bromide, okay. So electrolytic cell which we are using is the silica crucible. Let's just quickly recap everything. Electrolytic cell, silica crucible. Electrolyte is your molten PbBr2 lead bromide. What are the electrodes? The graphite rod, okay, the inert graphite rod. Temperature is greater than 380 degrees Celsius. Okay, temperature is greater than 380 degrees Celsius. Current is 3 amperes. Okay, dissociation, how it dissociates, your PbBr2 dissociates to form Pb2 plus plus 2Br1 minus ion. Very important. Okay, reaction at cathode. At cathode what happens? Gain of electrons. So what will happen? Pb2 plus will gain 2 electrons and what will happen? You will get your lead. Okay, silver grey color deposit which it will look like. Next, reaction at the anode, what will happen? This Br 1 minus, it will lose this electron and form your bromine. okay, in the form of fumes, reddish brown fumes. Can you see that? Br will give you what? Br, and Br will react and will form your Br2, the molecular bromine. Clear? Which is your reddish brown fumes. Moving on, electrolysis of acidified water, all the important reactions which are involved. Let's go through it. What is the electrolyte? Acidified water with dilute sulfuric acid H2SO4. That is your electrolyte. Your electrode is the platinum foil, which is inert. Temperature is your ordinary temperature. Current is 3 amperes. Dissociation takes place as H2SO4. Your electrolyte will dissociate to form 2H1 plus SO4 2 minus ions. Clear? Your water will dissociate. Okay, acidified water, right? Water will also dissociate to form H plus OH minus ions. Simple. Reaction at the cathode. What will happen at the cathode? See, H1 plus will gain one electron, 1 E minus, and become what? H. Okay, how many molecules? 4. So what you will get? 2H plus 2H will give 2H2. So how do you write that? 4H. 2H2. Hydrogen gas. This is the molecular form, right? So how many molecules? 2 molecules of your pure hydrogen gas will be evolved. That is your reaction at the cathode. Moving on to the reaction at the anode. What will happen? This OH minus, the OH minus ions which were formed because of the electrolysis of water, dissociation of water, electrolysis of water, what happened? This will lose one electron, it will form OH multiplied by 4, correct? So, for OH, how will you write it as? See, how you will write it? 2H2, okay, from this only we are forming everything, and O2, oxygen gas will be evolved. You have to remember this. Okay, now we will see electrolysis of aqueous copper sulfate using active electrodes. Quickly, let's do the recap. Electrolyte is what? Aqueous copper sulfate. We are doing electrolysis of aqueous copper sulfate, so that's the electrolyte. Electrodes are your copper which are active, not inert. Okay, temperature, ordinary temperature. Let's see the reaction. Current is 3 ampere, dissociation is important. Copper sulfate will dissociate to form Cu2 plus SO4 2 minus. See the ions that it forms. H2O, H2O will form what? H1 plus OH minus. This much is understood? Okay, next. What will be the reaction at the cathode? This Cu2 plus, okay, will gain electrons to form copper, pure copper, which is brownish pink deposit that you will get. You got copper? Okay, next what will happen at the anode? What is your anode? Your copper, correct? Your copper metal. That copper will lose electrons in the process, and it will lose electrons and it will form ions. Which ions? Cu2 plus ions. Okay, so no product is formed here, instead it forms Cu2 plus ion because the anode which we are using here is copper. So I hope that is clear to you. Now let's move on. When we are using inert electrodes, okay, the electrolyte is copper sulfate, same aqueous copper sulfate. Electrode here is platinum or carbon, which is inert. See the difference, okay. Let's see the reaction then. Temperature will be ordinary, current same 3 amperes. Dissociation also same, Cu2 plus SO4 2 minus. H2O will form H plus OH minus. Cathode reaction and the anode reaction, see what happens. Cu2 plus will gain electrons and form the copper brownish pink deposit. At anode what will happen? Your OH1 minus will lose electron and form OH twice, and from that what you get? H2O plus O2 and oxygen gas will be evolved. Okay, so instead of copper ions getting formed, here we have oxygen gas that is getting evolved. So there is a note for this. With active electrode, anode diminishes in mass. Why? Because it loses electrons. We saw that, right? Blue color copper sulfate remains unchanged with copper electrode but fades with inert electrode, because if copper anode is used, for every copper ion discharged at the cathode, a copper ion is added to the soul by the anode, correct? Because anode is also simultaneously producing your copper ions, right? Total number of copper ions remains unchanged. That is same, okay. This is not the case with inert electrode. So we also saw the reaction with inert electrode here, okay, when your oxygen gas is liberated, because here we are not using copper as the anode, we are using hydroxide as anode. Okay, let's move on to electroplating. You know what is electroplating, right? Electroplating with nickel, let's see all the important reactions. Electrolyte is aqueous nickel sulfate, cathode is the article to be electroplated, anode is the block of nickel metal which will be electroplated on the article. Dissociation, how it will happen, your nickel sulfate, your electrolyte will dissociate to form Ni2 plus and SO4 2 minus ions. Simple. H2O will dissociate as H plus and OH minus ions. Important reactions. Reaction at the cathode, what will happen? Ni2 plus which is there, it will gain electrons and from nickel metal. Okay, and that will be deposited. This is what we want, right? We keep the article at the cathode so that your nickel is deposited on that. That is your electroplating. And what is happening at the anode? Your Ni, it is losing electrons and forming what? Ni2 plus. Your anode is what? Nickel metal, pure. It will lose electrons, it will from that metal atom, it will form ion. Which ion? Ni2 plus ion. So no product, what you get? Ni2 plus ion is formed. Okay, so I hope electroplating with nickel is clear. Let's see another electroplating with silver. Okay, what is the electrolyte used? You are using sodium silver cyanide. Okay, sodium silver cyanide. What is the cathode? Cleaned article that is to be electroplated. Anode will be the block of silver metal. Dissociation, see the dissociation is very important. Na1 plus Ag1 plus 2Cn1 minus. The charges are plus and minus like that, only one. Correct? H2O will dissociate to form H plus OH minus. Then reaction at the cathode, Ag. Okay, what is happening at the cathode? Your Ag ion, that is your silver ion, will gain electron to form pure silver Ag and that will be deposited. Correct? And what will happen at the anode? Your Ag which is there, your silver metal, will lose electron and form Ag1 plus. Same, opposite reaction, but correct? No product, Ag1 plus ions are formed. Moving on, electrorefining of copper. So what is the electrolyte? Copper sulfate. What is the cathode? Pure thin sheet of copper. Okay, that is used as the cathode. What is the anode? Impure block of copper. Okay, so you are refining, right? So impure block of copper you are going to keep. Let's see the dissociation of copper sulfate, your electrolyte, Cu2 plus SO4 2 minus, that we know. Copper sulfate dissociates to form copper ion and sulfate ions. H2O, similarly H plus OH minus ion. Reaction at the cathode, see what is happening at the cathode. What is the cathode? Your thin pure sheet of copper, and this is impure block of copper. So this is the pure one, okay, cathode is the pure one. So what is happening there? Your Cu2 plus, okay, it will gain electron and form your pure copper Cu, that will be deposited, right? And what will happen at the anode? Okay, your anode is this your impure block of copper. It's copper only, right? So it will lose electron and form Cu2 plus. Your ions, Cu2 plus ions will be formed. Okay, so I hope this is how it gets refined, right? So I hope electrorefining of copper is also clear. So I hope you have understood and you have reviewed all the reactions which are there in your chapter electrolysis. Go through it, revise it, best of luck and thank you.